Hey scholars, so this is take 2 on statistics. I got lots of questions about different aspects of yesterday's presentation and what happened today in class. To the people in first period, I apologize for being late to class because I had to go get the computers and they were not in the place that I expected. So, and thank you for not hurting yourselves when I wasn't there. Okay, so today I'm going to review some of the items that I didn't discuss in the first statistics one, so maybe this will clarify for you what you need to know. So a histogram is a type of graph in which you are counting the number of times something happens. So for example, we have breakdowns here from, like for a test, we have 60 to 70. This next one is 70 to 80. Next one is 80 to 90. And I know I'm squeezing it in, but maybe we have, so if this is 10 and that's 5 people, we have, to make this last section 90 to 100. So maybe the average in the class was 75. So if there was a normal distribution, of scores, the largest number of people would have the average, the largest number of people would have the average between 70 and 80. So maybe we say 10 people have test score of between 70 and 80. We have maybe 7 people. This chart is not to scale. We have about 7 people who got between 60 and 70, and we get 7 people between 80 and 90. And if you do this, if you fill this kind of curve out, you notice it looks like should look like a bell curve, or as we call a normal distribution. Okay? So when you do the statistical analysis, like we did in class today, we can calculate standard deviation. And some sets of data have large standard deviations, and some sets have a small deviation. We have data set A, and we have data set B. So please write these numbers down and pause the video. And now that the video is playing, you're going to take a quiz. So, and now you have 2 graphs, so make sure you copy these 2 graphs down. So we have one which is like a more flat bell curve, and you have a thinner bell curve, right? But they're both normal distributions. So we'll call this graph, we'll call this one A, and we'll call this one B. Make sure you draw them out and pause the video right now. And now that you're playing the video again, we're going to take a quiz. Okay. There's the other thing I talked about, that when you have a bar graph, and you have an error bar, the distance of the error bar that you see from the top of the bar, which is the average for the data, you go up 1 standard deviation and down 1 standard deviation in order to know the size of the error bar that you're going to draw. The same thing here. The size of the error bar from there to there, this distance is 1 standard deviation for this set of data. Same thing down here, from there to there, these 2 distances should be the same. The next part that I'm going to go over is, when do you do a t-test and when do you do a correlation? And we're going to do these calculations in class on Friday. So a t-test, you do a t-test when you're comparing 2 measurements that are the same in 2 populations. So what do I mean by that? So if you remember back to my previous video, I said that you have a mouse that's fed a regular diet and you have a mouse that's fed a low-fat diet. You're comparing the weight, which is two measurements that are the same, right, in that example, the weight. You're measuring in two different populations. The two populations are the regular diet mice and the low-fat diet mice. You do a correlation when you're comparing two measurements, we'll say. We're running out of space here. Two measurements from the same population. So remember in the previous video I had said the crime versus the number of police? Well, that would be for a certain area, right? So the same population would be the area like Chicago, and you see a lot more police usually on, maybe you would say, the south and the west side because the crime is higher there. So you're comparing the crime and the number of police there. Okay? And now you'll take a quiz.